I think a lot of people in the lay public do not even know what fusion is. Let me tell you why I think fusion's important and why I think I got into it when I first learned about it. The thing about fusion is, for example, that the energy that you can get out by combining two hydrogen atoms, namely fusing two hydrogen atoms, it makes a helium atom. Einstein had this formula that energy equals mass times the velocity of light squared, that you can convert mass into energy. So what happens is when you put two hydrogen atoms together to make helium, some mass disappears, and it appears as a great burst of kinetic energy of the particles. And it turns out that the amount of energy that produces per pound is a million times more than the energy that's produced from burning the same amount of coal in terms of mass. And even compared to nuclear fission, which is the splitting of uranium, that also is a nuclear process that makes energy, fusion per pound gives out 8 times more energy per pound of mass converted than fission. So fusion is probably the most energy intense for a small amount of fuel that you can get. It takes, for example, to run a power plant, say 10,000 carloads of coal in a year to run one of these power plants. You get the same amount of energy from that power plant in a year. How much fusion fuel do you need? You need a half-ton pickup truck worth of hydrogen fuel. So a small truckload of fuel goes into the plant. It runs the whole year in fusion. But for a coal plant, 10,000 carloads of coal. They all have to come in. They burn the ash. They all have to come out, be disposed of. So fusion is an ideal energy source from that point of view. But the process itself is very simple. You get hydrogen from water. You take these hydrogen atoms, you heat them to a very high temperature like exists in the sun. When that happens, these fusion atoms combine by banging into each other, and they form helium, and the mass disappears in the process, in the nuclear conversion process, and you get way more energy for a very small amount of mass compared to any other energy fuel source that you can think of. Oh, except for solar and wind, of course. This year is my 50th anniversary of being in fusion. I started in 1962. I've done research in fusion, I've been in the management roles in the government, and I've been in this nonprofit foundation for a long time. So I've been tracking fusion progress and been involved in lots of conferences and things for a long time. And it occurred to me a few years ago that no one is putting all this story together about what the history of the fusion program is. I got interested in fusion because of a history book that was written that only spanned 10 years of the first 10 years of fusion. Since then, there was a book that talked about the history of fusion up to like 1982. So that was 20, 30 years ago. So I decided a few years ago that I would write a book on the history of fusion. My book is called Search for the Ultimate Energy Source, a history of the U.S. fusion program. And it tracks not the detailed technical accomplishments of the program, although those are in the book, but primarily the political ups and downs, the budgetary ups and downs, the management ups and downs, the changes of policy from one president to another, from one agency to another. We've gone through Atomic Energy Commission and became the Energy Research and Development Administration. Now it's the Department of Energy. Every time these changes happen, something happens in the fusion program in terms of momentum, in terms of policy, and in terms of budget. And I thought someone ought to lay all this out and track it through time as a contribution to the history of the program. So it's sort of a legacy, if you will, of my perspective in my career in terms of that aspect of the fusion program. And I hope it makes a contribution to the literature, if you will. I don't expect it to be a New York Times bestseller. I hope it will give new people coming into the program a perspective on the program and how they fit in, and what they may be up against during their career in terms of not being able to accomplish the things that they want to because they can't get the money for it or whatever. So that was my intention, and my book should be coming out next year in 2013. In the 1970s, I was a manager of the fusion program at the Department of Energy, and a congressman named Mike McCormick, he decided that he would put a bill together, which he did with Senator Paul Tsongas in the Senate, and they passed this bill, and Jimmy Carter signed this bill. It was called the Magnetic Fusion Energy Engineering Act of 1980, and it said, let's have fusion by the year 2000. I was at the department at the time, and it built on the plan that I had written in 1976 that had these different budget profiles in it. And so I decided that in order to implement that kind of a program, to have fusion by the year 2000, we needed to bring in industry. So I contacted a bunch of people in the industry, and with support from 10 industries, we formed an organization called Fusion Power Associates, which I am still president of today. Myself and 2 other people, we incorporated this as a nonprofit foundation. Its purpose was to bring industry into the fusion development program to do the engineering and development that would allow fusion to become a practical energy source. And for about a couple of years, that looked like that could be done. But when we didn't get the money for the first fusion engineering test reactor during the 80s, the character of my organization started to change. Because electric utilities, for example, that were going to be our customer, they got deregulated. They started thinking about, they were taken over by budget people who were thinking about near-term profits rather than long-term energy sources. And so a lot of things happened during the last couple of decades to my organization, where our original purpose was to bring in industry to do engineering development, and we had to evolve as the policies evolved so that we started to become more interested in the research. We brought in more of the laboratories and universities into our organization. We started to lose some of our industries, and we've become what do you say, go with the flow, if you will, of government policy to try to keep the hope alive that someday we'll get to fusion. So we run a lot of conferences. We try to keep all the different parts of the fusion community, if you will, talking to each other. They don't always talk to each other. There's a lot of competition between different people with different ideas. I try to keep them all talking to each other by running these management level conferences, by putting out newsletters in which I advertise all their different kinds of results so that they see a little bit about what each other's doing, because there are a lot of specialized areas in fusion, and people tend to work, especially physicists, they work in their own little areas, and they don't think about the big picture very much anymore. So for those reasons, Fusion Power Associates has become kind of a melting pot, if you will, for all the different constituencies in fusion. But we've never let go of the other element of our goal, which is in order to have fusion supported by government, we have to have a certain amount of congressional support, an understanding, and a certain amount of public support. And so we try to make sure that we participate in that educational function also. There is one thing that I would really like to emphasize. Fusion is an energy source, but it is not the only energy source. We have a problem with energy in the future. The population of the world is growing. All of these people that are in developing countries need energy, and this is going to create great demand. Most of our energy today comes from burning of fossil fuels. Many people in the world, especially the scientific community, believe that continuing to burn these fossil fuels is going to create global warming and damage our life in the planet as a whole. And so we're going to need new energy sources. We're going to need a lot of energy sources. We're not going to have just one energy source. Fusion is not going to be the only energy source. We're going to need every energy source that we can get. We're going to need to develop wind. We're going to need to develop solar energy. We're going to develop nuclear energy, and we're going to need to develop fusion. And so we have to take the long view. These things take time. New energy sources do not come into play overnight. They enter the marketplace slowly with time, and we have to understand that time is in a sense running out, not maybe on a 5-10 year scale, but on a 50-100 year time scale. We have a real energy problem, and we need to develop every energy source we can get. And one of the very great benefits of fusion is that it's not just a small-scale energy source that's going to make a small difference. It's a huge energy source. The fusion power plants are large. They make lots of power from a very small amount of fuel, and so they are going to be what we call base load. They are going to provide not just small niches here and there for this or that out in the deserts or wherever in the mountains. They're going to be running our cities for electricity and for other things. Fusion can make not just electricity, but it can make other things. It can do, for example, desalination of water. Water is going to be a big problem on the planet as time goes on. So there's many reasons to develop fusion, but it's not the only energy source, although I think in the long run it is going to be one of the most important energy sources. Not next year, not in 10 years, but in the 20, 30, 50, 100-year time scale, fusion is going to be essential for the planet.